Hello everyone, today is day 68 of solving a LeetCode problem every day, and today I'm going to be solving count good nodes in binary tree. So first of all, I hope everyone had a great Thanksgiving. I didn't have any of my stuff, and I went back home for Thanksgiving break, so that's why I haven't done any problems in a couple of days, but now we're back on track, so everything is fine. So today I'm going to be solving count good nodes in binary tree. So given a binary tree root, a node X in the tree is named good if the path from root to X, there are no nodes with a value greater than X. So all that's pretty much saying is that we're going to have some node X. So for example, that can be the node 3 over here. And if there's any node which has a value that is greater than 3 from the path from the root to that node, then that means that's not a good node. So for example, in this node 1 right here, its parent node is 3, and 3 is greater than 1, so that is not a good node. However, this 3 over here is a good node because there's no value greater than 3 in the path from this leaf node to the root. It's the same thing here, so this 4 is greater than 3, and the 5 is greater than 3, and the 5 is also greater than 4, but the 1 is less than 4 and 3, which is why it's not a good node. So the way I'm going to be solving this is using depth first search. Essentially the idea is we don't have to recalculate the path for every node from the current node to the root. What we can instead do is just keep track of whatever the max value is in the path. So like for example, we're going to start at the root. So the max value now is going to be 3. And then we want to recursively call the method again on the left node and right node. So what we can do is pass the fact that the current max value is 3 to the left side and the right side and call it again. So now we can see is 1 greater than that max value? It's not, so this isn't a good node. So what we're going to do is again call the method to its children and pass the max value. We're going to do the same thing to the right side. So we check, is 4 greater than that max value? It is. So what we're going to do is we're going to set max value to be 4 now since it's greater than 3, and then pass that max value to both children 1 and 5. So this is what the solution is going to look like. So we're going to call this method just depth first search. It's going to take a root of the subtree that we're looking at alongside a max value. So our base case is going to be if the root is null. In that case, we can just return 0 since we're not adding anything to the output. The next thing we're going to do is to the response. So the current, I guess, output for the subtree is going to be 1 if the root dot value is greater than or equal the max value. Otherwise, it's going to be 0. And then we're going to also set max value to be the max between root dot value and max value. So what this does is, let's say we're at 4, current max value is 3. You want max value to be 4 now since 4 is greater than 3. Then what we're just going to do is we're going to append to response, just recursively calling the method to the left and right subtree. Then finally, we're just going to return the response. So essentially, like we start out at the root, we see that response is going to be 1 since 3 is greater than or equal to 3. And then we call the same method on the left and right subtree, and then that's going to return the response, and that just gets added back to the root value. So basically, we start at the root, but then we're recursively calling this method. We reach the leaf nodes, and from there, we basically just send back how many good nodes there are back to the root. Finally, all we need to do is just call the method. So we're going to pass in the root alongside the the root's value as the max value. And the reason why is because, when we start at the root, the current max value is just going to be the root since that's the only node. And we actually want to return this. So if I run this, accepted, submit it, also accepted. So the time complexity of the solution is going to be O of n, and the reason why is that we're just going to process each node once, and then the space complexity should be constant, but I guess one thing you want to know is going to take n amount of space on the call stack since we're going to be recursively calling this method. So yeah, that's my solution for the day.